Hey guys, let's discuss new problem from graph, which is called Dijkstra algorithm for minimum distance. Okay, so let me remove this. So why we use Dijkstra algorithm is basically it is used to find the shortest distance from source node. Okay, and other nodes in a weighted graph and non-negative weights. Okay, this is the main thing, non-negative weights. If the weights are negative, then you use Bellman-Ford. Okay, and so when to use Dijkstra, graph is weighted, and then we need shortest path, and all weights are non-negative. Okay, so let's say this is the example. You have given adjacency list and one graph. Okay, now you will store you will store nodes in terms of pairs. So pair means you will have node plus distance. So from 0 to 2, let's say 0 to 1. Okay, in adjacency list, how you will store the pair? 1 comma 4. So 1 is the node and 4 is the distance. Then 2 comma 4 till 2 is the node and 4 is the distance. Okay, something like this. So now how you will solve it? See, you would be needed one distance array. This is array, right? Not queue. Okay, and here we will use a priority queue because I'll tell you why. So first you will use distance array. Okay, how many nodes do we have? 0, 1, 2, 3, 4, 5. And then we will use priority queue. And why we are using priority queue? So priority queue will give me the minimum distance pair first. Okay, so here if you check priority queue, we are using lambda expression a comma b, where a distance minus b distance. So it will give me the distance. Okay, and how it will and then initially all the distance will be infinite, and because 0 is my starting node, the distance for that is 0. Okay, initially I will put 0 comma 0, means to reach node 0 it took distance 0. Okay, so let's say I'm using first distance and then node. Okay, so now I will check all the elements. So I have put this 0 comma 0 into the queue, and now I'll pull the element from queue. Okay, and I will traverse all its adjacent node. Okay, so who is adjacent node of 0? It is 1 and 2. Okay, first one is node and second one is distance. So 1 and 2. So let's check for 1. See, to go if till reach 0, it is taking 0 distance. Okay, and then from 0 to 1 if you wanted to go, so you need to take 4, right? So the new distance will be 4. And what is the current distance for 1? It is infinite, so I need a shortest one, right? So I will take this 4. Because I'm taking this 4, I will put this pair into the queue, 4 comma 1, where 4 is the distance, 1 is the node. First one is distance, second one is node. Okay, now it's time for 2. So till reach 0, it is 0 distance. Okay, and to reach 2, what is the distance? It is 4, right? So my distance, new distance will be 4 for node 2. Again, it is lesser than the existing one. Okay, so I'll take this and I'll store this 2 comma 4 into my, means 4 comma 2 into my queue. Now I'll take now I don't have any adjacent node for this 0. Okay, so now I'll take element from queue. Which element you will take? You will take this 4. See, the distance is same for both, but the node who is coming first is 1. So that's why I'm taking 4 comma 1. Okay, I'll remove this. I'll remove this thing. Okay, now it's time for 4 comma 1. Okay, who all are neighbors of 4 for 1? So for 1 it is 0 and 2. Okay, 0 and 2. So to reach 1, I'm taking 4 distance. Okay, and from 1 to 2 if I go, how much distance it would take? 4, which is 8, and my current distance is 0, so I'll not take this one. Okay, now it's time for 2. So now to reach 1, it is taking 4 distance, and from 1 to 2, how much distance it will take? 2. So it will be 4 plus 2 is 6. Okay, so for 2, the new distance is 6. So no, I'll not take this one also, because I have existing one which is 4. Okay, so we will not add anything from here, and now I don't have any neighbor also for it. Now it's time for this 4 comma 2. Okay, 4 comma 2. So now 2 is my neighbor. So 2 is connected to whom? 2 is connected to everybody. Okay, 0, then 1, and then 3, then 5, then 4. So let's take one by one. Okay, if I need to go to 0 from 2. Okay, so to reach 2, it is taking 4 distance, this one. Okay, and then from 2 to 0, it is again taking 4. 4 plus 4, 8. No, I'll not take that because I already have 0, right? For 2 to 0. Okay, now from 2 to 1, let's check for 2 to 1. Okay, so for 1 we will be checking. So to reach 2, it is taking 4 distance, and from 2 to 1 it is plus 2, means 6. I already have 4, I don't need to. Now let's check for 3. Okay, to reach till 2, it is taking 4 distance, and from 2 to 3, it is taking 3 distance, so 7. Okay, and what is the current one? It is infinite, so okay, I'll take 7, and then I'll put this pair into my here in my queue, 7 comma 3. Okay, now it's time for 5. So to reach till 2, it is taking 4 distance, and from 2 to 5, how much distance? 6. So 4 plus 6 is 10, and we are talking about 5, right? So yeah, 10 is lesser, so I'll take 10. okay, and I'll add this pair into my queue. Now it's time for 4. So to reach till 2, it is taking 4 distance, and from 2 to 4, 2 to 4, it is 1, so means 5. Okay, so for 4, it is taking 5 distance, so I'll take this 5. Okay, now it's time. Now all the nodes are done, so it's time to pull the element from queue. Now which one will come first? How much you have added? See, 3 is done, 5 is done, and then for this 4 also we need to add. Okay, 5 comma 4. So now which one will come? 5, 10 or 7? So 5 comma 4 will come because the distance is minimum. Okay, between this 7, 10 and 5, 5 is the minimum one. We are using priority queue on the basis of distance. So 5 comma 4 will come into the picture. Okay, now who all are neighbors of 5? So 5 neighbors are one is 3, second one is 2, and third one is 4. Okay, so 4 is the distance. Okay, sorry, 5 is the distance and 4, I'm sorry, my bad, I just got confused. Fine, so 5 comma 4, so 5 is the distance and 4 is the node. Okay, so what all are 4's neighbor? It is 1 and 5. Okay, to reach till 4, it is taking 5 distance, and from 4 to 5, 4 to it is 2. Okay, so from 4 to 2 it is 1, so 5 plus 1 6. So for vertex 2 it is taking 6 distance. I have currently 4, so I'll not replace it. Now to reach till 4, it is taking 5 distance, and from 4 to 5 it is 3, so 5 plus 3 is 8 for fifth node, and currently it is 10, so I'll take 8. Okay, now I'm taking 8, so I'll add that into my array 8 comma 5 queue. Okay, now all the nodes are done for this 5 as well, right? So now it's time for pulling the element from the queue. The next I will get, which one I will get? 8, 5, 10 or 7. Okay, 5 comma 4 is done. So now 7, 10 or 8, so I'll get this 7 comma 3. 7 is the distance, 3 is the node. So who all are the neighbor of 3? It is 2 and 5. Okay, so to reach till 3, I'm getting 7 distance. Now from 3 to 2, it is 3, so 10, right? So for vertex 2, it is 10, so no, I'll not take that. Now for 5, so 7 plus 3 to 5 is 2, 9. Okay, currently I have 8, so I'll not take this one also. Okay, it's time again to take a pole from queue. Okay, so now which one will come? Now 10 or 8? 8 comma 5 will come, right? 8 is the distance, 5 is the node. So from 5, who all are neighbor of 5? It is 3, 2 and 4. So to go till 5, it is taking 8 distance. Okay, and 5 to 3 it is 2, 5 to 2 it is 6, and 5 to 4 it is 3, and you can add 8 into that. Okay, so this one will be 10, this one will be 14, and this one will be 11. So 3, 2 and 4. For 3 it is 7, so I have current one 10, so I'll not take that. Then 2, it is 4, current one is 14, no, definitely not. And then for 4 it is 5, so it is 11, so I'll not take anything. Okay, again I'll pull element from queue. So how many elements are remaining in queue? Just one, 10 comma 5. Okay, so this 10 comma 5 will also come out. So distance to reach till 5th node, it is 10. So who all are neighbor of 5? It is 3, 2 and 4. So 5 to 3, the distance is 2, 5 to 2, the distance is 6, 5 to 4, the distance is 3, and add 10 into that. So definitely it is more than anything what I have in the my distance array. So now I have nothing in the queue, so this one will be my answer, this array. Okay, now what is happening in the code? We can see you have given adjacency list, and then vertex v. You'll create one dist array, and then you will fill it with infinite. You can create one visited array also for all the nodes to check all the nodes. Okay, and then you will run one for loop. You will check if the node is not visited, then you will create one priority queue, and here is the lambda expression for the priority queue: a ka distance minus b ka distance. Okay, so on the basis of distance, minimum distance, it will return the element. Now dist I will be 0. Okay, initially this is our starting point, and then you will add that dist I to pair 0,0 into the queue. Now until queue is not empty, you will run this code, and what is happening in this code, you will pull the element from code, you will check if it is not visited. Okay, then you will mark it to true, and then you will check all its neighbor node. Okay, and you will get the new node and new weight, and you will check the distance. Okay, which one is lesser? So if it is lesser, then you will assign the new distance to the distance node, and then add that pair into the queue, and at the end you will return this dist array, this one. So that's it. Thank you.